From today, we will discuss some tree problems. Today, we will start with LeetCode Problem 100 symmetry. This is an easy one, and we begin with it. First, let's see the description of the problem. Given the roots of two binary trees P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So generally, we have two algorithms to solve tree problems. The first one is recursion. The other one is to use queues with BFS, breadth first search, or DFS, depth first search. So today we will begin with the first one, recursion. So for symmetry, we have two cases. So if we meet one of the cases, the two trees will be the same. The first one is P and Q are all empty trees, which means the root P is none. At the same time, the root Q is also none. The second one is a little more complicated. So the trees will be, we will check whether these trees structurally identical and the nodes have the same value. So firstly, both P and Q should not be empty trees at the same time. And then the root value of P should be equal as the root value of Q. And at the same time, the left subtree of P should be the same as the left subtree of Q. And the last one is the right subtree of P should be the same as the right subtree of Q. So if we meet these requirements at the same time, tree P will be the same as tree Q. And for other cases, P and Q will not be the same. Yeah. Then we use Python to fulfill the conditions. So in the first case, we need to check whether P or Q will be none. So actually, we have two functions to fulfill this. One is P equals none and Q equals none. Or we have not P and not Q, because if P is none, not Q should not be none, and then the Python will return true. So not Q, we always use like not Q to check whether P is none or not. And for the second case, we have P and Q to check whether they are empty. Similarly as this one, if P is not none, the Python will return true. So if P is not none, we will have here is the true, and if Q is not none, we will have this one is also returns true. So then we will check the root value of these two trees. So P dot value is the root value of P tree, and Q dot value is the root value of Q tree. So we will check whether they are the same. And then we use recursion to check the left subtree of P tree and then the left subtree of Q tree. So P dot left will be the root of the left subtree of P tree. Similarly, Q dot left will be the root of Q subtree of Q tree. So if this recursion function returns true, which means the left subtree of the P tree is the same as left subtree of Q. Similarly, we have the recursion function is symmetry. Like we will check the right subtree of P and then the Q subtree of P. So after the recursions, this one will return whether P and Q trees are the same for fulfilling these second cases. Besides these two cases, in other cases, P tree and Q tree will not be the same, so we return false. Okay, let's submit our answer first. Yeah, it's success, which means we solve this problem. Then we discuss the time complexity and the space complexity of this problem. So in this recursion, we will recursively traverse the whole trace, so we have time complexity as O(n). For space complexity, because we use recursion, so we will have nodes stored recursively in the stack. So we will in the worst case, we will store the whole trees, so we have the space complexity as O(n) as the same. Let's end up now. So from tomorrow, we will discuss more tree problems, and we may use queue methods or use recursion to solve more difficult problems. See you. Bye bye.